Hello, everybody. I thought it would be nice to give you a few pointers for the modeling and the drawing for this week's assignment, as there's quite a lot of new stuff that we haven't practiced too much. Basically, making a drawing of an assembly, which is quite easy, but then you always have to do sections. And as you might remember, we have to do a section within a section. I want to make a few comments about this. Secondly, I want to show you one or two tricks about, well, just regular features. So I'll go right in because this shouldn't be a long video. I'm just sharing my screen and going into the CREO. So this is the feather key. I have the dimensions according to the shaft diameter that I have. Maybe I'll just show you the background. So this is the little assembly for now. It just has this V-groove, this V-belt pulley, and this bit of a shaft. Now in real life, the shaft is always a lot longer, has more features here, but we're just interested in the end of the shaft. So we'll kind of break this off in the drawing. And for now, all I have in the drawing is this, right? So a full section of this side view. And what is missing for your assignment is, of course, the design features for the feather key. Could be here, could be that. It's the same. And in order to show that, we need a local section here. Secondly, we might want to break this off here just to indicate that the shaft will go on in real life, but we're just interested in showing this bit. And what I'm also asking from you is a side view, a view here, which is a section view going through the feather key, which we don't have yet because we need to show the dimensions of the feather key. So I'll start with the feather key just for one little feature which is useful. As you know, we've talked about the feather key. If you want to use the full length of the groove, you must round off the edges. So of course, the round command or feature is quite easy to use and well known, but I want to show you something special. So normally you would enter a radius half the width of this thing. But I want to show you a more elegant way of doing that. So if you selected the two edges that belong together in the full round, you can then select full round, and this is what it does. So you don't have two separate rounds anymore. It creates this one round, and it automatically uses, of course, the correct radius. So we have two ends to round. You have to do that with new set, and then again with the control button down, select these two, then choose full round. So these are two sets because we have two sets of full rounds for four edges. So that's one thing. You can save that. So I forgot my dimensions. This is 40 long, 14 wide. Of course, you receive this table in the exercise, so you should select the feather key and groove dimensions according to your shaft diameter. So the next thing is still about modeling what I want to show. We now have to put this groove into the shaft, into this shoulder, into the smaller shoulder. And you might be wondering how to place this. Because the depth is measured from the first contact of the end mill that will cut it. But this is a round surface, right? So you can't just click on the surface. We need to create a new datum plane, and it should fit, the orientation should fit the orientation of the drawing. Not quite sure. I used the front view, but anyway. So what I need is a drawing plane that is parallel to this one, but it should be tangent to the top. So let's try if it's possible to generate this plane. Of course, we'll start with the datum plane feature here. Click on this. Later on, we want to say, well, or we can say now it should be parallel. And now the trick is to select this surface and don't go through it, say tangent. And then this will give us this plane, which is perfect for creating the feather key groove. So let's do that. Extrude, cut material, and then in our little table here, we have the information that in the shaft, the groove depth should be 5.5. So we can already enter that, even if we haven't sketched anything. And then we choose this drawing plane. If you placed your shaft correctly already, you'll have a nice reference here. And I will use a center line because, of course, this cutout should be symmetrical. And I plan to use the full round command again, so I will not actually sketch the rounds of this groove. The groove needs to have the rounds. In the lecture, we saw the video of how it's created. So I think my hub is 45 millimeters long. And what did I just do? I think I made the feather key 40. So the distance to this surface here would be 2.5. And this would be 40 millimeters long. It's, I believe, 14 millimeters wide. And that should be it. So this is what I wanted. Of course, this is not the finished shape. We've learned it's not feasible to create a groove like that because it is not impossible. There are technologies to do that, but it's not feasible. But in real life, we would probably mill this with the sides, end mill, side mill. So I'm going to put in the same rounds, full rounds that are used on the piece that goes into that thing. So I don't have to define the radius because it's already implicitly defined by the width of this. New set, click, clack, full round, there you go. Smash, perfect. So if you check this out in the drawing, you cannot really see it, but you can see a little bit of it because think of it, this is a cutout on a cylinder, so the sides of the cutout come down a bit. So even if I excluded the shaft from this section, you can already tell there is a groove there. But we want to actually see the feather key. So to be honest, shall we first put in the feather key into the assembly? Why not? So logically, we can't put in the feather key after we put this hub on this pulley. So what I will do is I will slip back my cursor here, and I should now find the feather key groove. Indeed, there it is. And now I will assemble the feather key in there. Snap. And there are many ways to do that. I would actually use the actual component surfaces. So surface on surface. And now I can actually coincide these partial cylinder surface. Now don't do the allow assumptions. Don't allow that. Explicitly fully constrain it. So think about how many constraints you need. So I'm aligning both cylinders to make 100% sure this is what's going on. So now going back into the drawing, of course, because I stepped into the model tree just before we entered the hub. We have the feather key, but not the hub. So that's easy to fix. I'll just slide that back down. Come on. There we go. Going back into the drawing, we have all of this. This is not perfect yet. First of all, there's the groove missing. Okay, let's go. Again, I'm hoping that I could, but it's hard to tell. I'm trying to find out how this thing is oriented. Just want to make sure that when I'm modeling the groove. So Okay, great. Yeah, so it's the correct orientation. I want to have the groove so I can see the section in the front view. So let's go into the part. Where is my, I haven't opened my part yet, no problem. Let's just open it from here. Open the file. So I left-hand click, right-hand click, groove. And this time it makes sense to sketch and model the card similar to the manufacturing process. And we remember that what we're doing is we're pushing a broaching needle into that hole. So why not sketch it exactly like that? So I'm creating a cut. Here the depth is not defined by number, but it goes all the way through, and I sketch on that surface. But I don't like my orientation. I want to sketch it in the how I imagine it in a drawing. So I might just be changing the orientation of the sketch. I like top to be on top. It's way easier for me to imagine. Now I want to put the groove up here. And we have a similar problem as with the shaft. For the depth, we want to reference the cylinder. So I need the cylinder as a reference. This is why I opened this reference menu, then click on the cylinder surface. And now I can actually, for example, place a point here at the intersection. And I can use this point to start references with. Now, did I already draw a center line? I believe not. This is symmetric, so I need a center line here. And then look how I sketch this. So this should be symmetrical. Look, you see the two little blue arrows. And now I can just use this point that I constructed as a reference to get the depth, which is supposed to be 3.8. And there you go. This looks exactly as it should. And if I now go back into the drawing, I realize that it's on the wrong side. Not a big deal. I will not change the feature in the part, but what I will do instead is I will change the orientation of the part in the assembly, as I would in real life, you know? So, actually, see, this I was lazy. I didn't fully constrain it. I can still add one more constraint to define the orientation correctly. And I will use the front surface on both parts. Actually, I can click on it here in the model tree. And now I can flip it. And now it's fully constrained. Now I have the groove where it is supposed to be. Okay. So there's of course more to do, but the rest of the stuff is quite easy, like the circlip groove and stuff. But one thing we need to discuss, no, actually, sorry, two things. First thing is the local section. We need a local section here to show the well, the groove in the shaft to show the feather key. But firstly, I don't actually want to cut the feather key itself. So I will edit this section. And I will go next. So now the feather key is highlighted. I say exclude. So that means no hatch on the feather key. And now you can see the 0.3 millimeters. In class, I said you might have to change that, make it deeper than it really is. Let's not do that because I want you to put dimensions on these features today, okay? So, but if this was a hand drawing, I would exaggerate to make sure you can see the gap. So we want to have this other local section here. This is not 100% perfect in CREO, or at least it isn't in this old version that I'm using. So you go into properties and section, and we have to create one more section. So we just hit plus. So normally I'm thinking this is the same location as A, but it doesn't work. You cannot reuse A. although it's in the correct location, even as a local section, we have to create a new section in the same location. So it will get a new name B, and it will also go through the front surface. I click on front in the model tree. And now it's asking me to select a point and sketch a spline. That means spline would be that freehand line. So I'm clicking on any point that will be inside of the local cut, and then click a few times to define this local section. And then middle mouse to finish that, and then apply to see what I'm doing. This is not great. I see I was a bit too stingy here. I want to cut away more stuff, so I'll double click on spline define. Just go a bit deeper here. Apply. Now this will give us more to work with. Now this is not pretty. Everybody who is experienced will not like that we are using that this freehand line goes through the pulley because it's already cut. So I would hope this was different, but it's not. So we have to work with that. So just make sure, see, these are two different sections. So these are two different hatches to highlight. So I'm highlighting this second one. I double click it to change the properties. Now it's highlighting the hub, and the best I can do is just give it the same hatch as I used before in the main section. So I give it the same value and the same angle. And you see, it's actually perfectly aligned. This is one good thing. It remembers the position of the hatch. And then I don't want the feather key to be hatched. So I need to go next. And there's the feather key. I would just say exclude. And then just the next will give me this section, which is part of the shaft. I will give it the opposite direction, 135 degrees. And for the spacing, maybe a bit more, 4 millimeters. So that's pretty good. It's pretty good already. I don't really need these showing that this is section A, B, B, because it's clear. So I will right-hand click, erase that. So the last two things I will show you is now I want to create a section that goes through the feather key. And the best way to do that is to first create the section plain in the assembly. You can do that in the drawing, but it's less confusing if you actually do that here. So that will be somewhere here going through the feather key. And I will not let it go through the big part of the hub, but through the actual hub, the smaller hub. So it looks a bit less messy in the section. So best way to produce the section plane is just make a new plane and then click on the assembly datum that we can then offset. So that's ASM right. And you just drag this little white thing, this little brick here, to a position that will give you the position that you want. And we can rename that. We can call it section C in this case, section C. Now I can create my second view. First highlight this view and then create a projection view. Now this is a very boring projection view. What I want to have is this section so I can put dimensions on the feather key. I therefore create a new section, create new. It's going to be called C, and I select from the model tree. I could select it here too. I could just click on it here, but I prefer to click on it in the model tree. And I should indicate in this view where the section plane is. We do this with arrow display. So you click onto arrow display here, and then you select this one. Apply, you see what is happening. Wonderful. Okay. So we have indicated where the section is. You should move these arrows around to a nice position. And now we just edit the hatches in here to be identical. This is important if you show the same part in multiple views, you must use the same hatch pattern, right? So for the shaft, it's 135 with 4 mm spacing. So do the shaft first. And just realizing my feather key groove is completely wrong. Or maybe it's the feather key. So anyway, this one is cut in a cross section, not in a length section, but I haven't used the hatch here, so I'm still free. So I suggest do a 45 with a very narrow spacing of maybe 1.5 mm. Next gives us the shaft. I used the spacing of 4 before and the angle of 135. And finally, the next is the hub. I must use the same spacing and angle, so that's 3 mm and an angle of 45. Done. So now let me check out what happened here. I don't seem to remember specifying the width of this. Just double click it and it's something. It's 20 point. Yeah, I forgot. No problem. It's supposed to be 14 as far as I remember. Let's go back into the drawing now. It looks nice. And here we see that gap. Great. I'm sorry, there's one more thing I want to show you. And this is how to break this off. Now, I say break it off, but it's not a broken view, because a broken view would be broken off on two sides. We just break it off on one side. So instead, I redefine this view as being a partial view. So here under visible area, you go partial view, and now you basically you create a spline. Everything within that will be shown, everything outside will be not shown, and where our freehand line cuts through the geometry, will have this nice broken line. This is the effect I want. So again, first we have to click on any geometry point that will be inside. And now I can sketch the spline. And I'm being careful that I break through this shaft here. Middle click ends it. I can apply. Okay, this is exactly what I wanted. Yeah, and now for dimensions and center lines and everything, you can just show from the parts. You can show features here. For example, the first extrusion from the shaft, show model annotations. And I want to see, of course, I want to see some dimensions, but mostly what I was missing here was the center line. And that's it. Here, the CC we need, because it's clearly indicated. We can move these around to look prettier, although I don't know where. But so basically, there's one more thing I can show you. See these black lines here? They're wrong. These are tangent lines. They should either be invisible or gray. They're not real edges. So go to Properties, View Display, and then for tangent edges, you can say none. And then they're gone. Now it looks right. Just pulling that center line along a bit. There you go. So I know this is a lot of stuff, but we are a very intense course, right? Just 10 weeks for a lot of engineering drawings, so you have to learn quickly. And I hope this introduction here will solve some of your problems. This is not your finished assignment, but it's almost finished. What is still missing would be showing the circlip according to DIN 471. And I told you to download this on Trace Parts. And then finally, I'm asking you to put in a few more dimensions, specifically all the dimensions that are specific to your specific number. Not all the dimensions, but I want to have the shaft diameter. I want to have the width and diameter of the pulley as according to the assignment. And then in this view, I want to have the length of the feather key. In this view, I want to have the section of the feather key. So not too many dimensions, definitely not complete, but just specifically the dimensions that you needed to identify. Don't forget, circlip here. And that is only two dimensions that I need. That will be the diameter of the groove and the width of the groove, which we called D2, I believe. Yes, D2 and M. These two parameters, I want to see the dimensions in your drawing. Don't forget to fill in the title block with 3 items. Name of the part, your own name underdrawn, and the date of submission. And it's quite handy actually. You just click and then you can put in the numbers there. So it's no big deal. Just double click. No, that's not correct. Something like that. Okie dokie. So I hope you enjoyed that. See you in class next week. Thank you very much. So I wonder how I can end this recording. Bye-bye.